welcome to my revision video on upper and lower bounds. So first of all, let's look at how to find the upper and lower bound in different circumstances. So for the first question, we want the upper and lower bound when something is rounded to the nearest 10. To get the upper and lower bound when it's rounded to the nearest 10, you've got to add 5 and take 5 to the number. So that means that my upper bound will be 20 plus 5, which is 25, and my lower bound will be 20 minus 5, which is 15. So when it's rounded to the nearest 100, sorry, that shouldn't have an S there. When it's rounded to the nearest 100, we just take half of 100, which is 50, and we add 50 and we take 50. So that means that 1,700 rounded to the nearest 100, upper bound is 1,700 plus 50, lower bound is 1,700 minus 50. The third one, this time it's rounded to 1 decimal place. Now you've got to imagine 1 decimal place as 0.1. And in the same way, if I find half of 0.1, I get 0.05. So I add 0.05 and I subtract 0.05. What might be easier to do when it comes to decimals is if you imagine 35.7 as 35.70, so add a 0 there, and then think of that 70 and add 5 onto 70 and take 5 off 70. So it's just a little bit easier to do. So that would be, for the upper bound, 35.75. Not that it's correct to say 35.75, but imagine it like that. And the lower bound would then be 35.65. Okay, the next one is about significant figures. So let's just recap what significant figures are. The first significant figure is the first non-zero digit. So if I ask you for the second significant figure, that would be the one next to the first significant figure. First significant figure is the number, the first non-zero digit, which is the 9, which means the second significant figure is the one next to the 9, which is the 1. Now that 1 is in the unit position. So if I say that something's been rounded to or this number has been rounded to 2 significant figures, I may as well say that this number has been rounded to the nearest unit, which means you add half a unit on and you take half a unit off, which means the upper bound for this number 91 would be 91.5 and the lower bound would be 90.5. In the same way, if this has been rounded to 3 significant figures, the first significant figure is the first number that is not a 0, so that's a 7, which means the second significant figure is that 8, and the third significant figure is that 3. So that basically means that I want to round this number to 2 decimal places. To round it to 2 decimal places, again, if you use the same trick as before, if you think of this as 7.830, and then just imagine that 830 and imagine that you add 5 on and take 5 off. So that just works easiest for decimals. So the upper bound would be 7.835 and the lower bound would be 7.825. Okay, so the next 2 questions are exam questions. I'll go through the first one and then pause and have a go at the second one yourself. So this one, so the length of a rectangle is 35 centimetres, correct to the nearest centimetres. Now if you do an exam paper and you see the words correct to the nearest, then you know it's an upper and lower bound question. So it's rounded to the nearest centimetre, which means unit. So I'm going to go half a unit up and half a unit down. The width of the rectangle is 26 centimetres, also correct to the nearest centimetre. So that too will be add half a unit and subtract half a unit. So let's look at the upper and lower bounds for this then. So the upper bound of 35 will be 35.5 because I add half a unit on, and the lower bound would be 34.5 because I subtract half a unit. And 26 would be the same, add half a unit on and subtract half a unit. So those are the upper and lower bounds. Now the question says calculate the upper bound, so the upper bound for the area. So I want to work out what will give me the biggest possible answer for area. So if I want to get the biggest possible answer for area, I'd have to take my maximum possible length and multiply it by my maximum possible width. So the upper bound of my area will be upper bound of area, maximum possible length is 35.5, and I'm going to multiply that by my maximum possible width, which is 26.5. And the question asks you for all the digits on the display. So 35.5 times 26.5 would give you 940.75. Okay. Right, so before you have a go at exam question 2, I just want you to consider this. When you divide or subtract, things are slightly different. Because if I want you to get the biggest possible answer for D divided by F, think about whether you're going to use the upper bounds or lower bounds, or a mixture of the two. So pause this video and have a little go, and then I'll go through it. Okay, so the first thing we need to do for some method marks, it says D is 163 to 3 significant figures. First significant figure is a 1, the next significant figure is a 6, and the third significant figure is a 3. So what they're basically telling us is that that's been rounded to the nearest unit, which means I go half a unit up, half a unit down. So D, the upper bound would be 163.5, that's half a unit up, and the lower bound will be 162.5, that is my half a unit down. F has been rounded to 3 significant figures. Again, so first significant figure is that 4. Second significant figure is the 5. Third significant figure is that 3. So they're basically telling us that it's been rounded to the nearest 1 decimal place. And the upper bound for that, if I add 0.05 on, is 45.35, and the lower bound would be 45.25. Remember what I said before? Imagine that there was a 0 there and think of that as 30 and go 5 units up from 30 and 5 units down from 30. Okay, so there you'll already have yourself some method marks. So by considering bounds, this is a very typical exam question. By considering bounds, work out the value of C to a suitable degree of accuracy. You must show all of your working and give a reason for your final answer. So what they're saying is you need to just put down a value for C, but that value needs to take into account the maximum and the minimum value. So let me show you what to do. The first thing I'm going to do is work out the upper bound of C. So how will I get the biggest possible answer for C? So to get the maximum possible answer there, I'd have to use my biggest possible value of D and divide it by something as small as possible. So think about this for a minute. If I want my maximum answer, I'd have to take my biggest possible number and divide it by something as small as possible. That would give me the biggest answer. So my biggest possible value of D is 163.5. And if I divide that by the smallest possible F value, that's the smallest possible F value, 45.25. 45.25. And that will give me, and I'm going to write down more more digits rather than just round it straight away. So if I divide this, I get 3.61325969. So that's the maximum that my C value could be. If I look at the lower bound, now to get the smallest possible answer there, I need to take the smallest possible D value and divide it by something as big as possible. That would make my answer smaller. So the smallest possible D value would be 162.5, and I will divide that by as big as possible value there. So the biggest possible F value is 45.35. So 45.35. So if I calculate this, 162.5 divided by 45.35, I get 3.583241,455. Right, so the question didn't ask me to just calculate the upper and the lower bound. It wanted me to find a value for C, so just one value. So let's have a look at how to do it. If I round to one decimal place, I would get a 4 there, and I would get a 4 there. So I could say that my value for C is 4. But can I perhaps go a little bit more accurate? Let's try and round to one decimal place. If I round this to one decimal place, I'll get 3.6. If I round that to one decimal place, I would also get 3.6. So that could be my answer. Let's see if we can go even more accurate and round to 2 decimal places. So this rounded to 2 decimal places is 3.61, but this will be 3.58, so not the same anymore. So my best answer would be if I round to one decimal place, where both of them would give me 3.6. So my answer for C, to a suitable degree of accuracy, is 3.6. Okay, thank you.